Welcome back to another episode of Science Nights.
Hello.
Hello.
Hello. Tonight we are talking about astronomy.
Broad subject.
It is. That's kind of the point of this episode, just to go over some broad definitions, a little bit of history real quick of the stars.
The universe and everything, because
Pretty much.
apparently
yes.
this is everything.
Yeah.
As always, I'm Josh. That's Sir Peter.
Sir Peter with
I'm
a
Adam.
finger in his face.
And that's Maester Adam over there. He's forging his producer chain today. I guess to start off, what is astronomy, what is astrophysics, and what is cosmology?
So basically, astronomy can kind of umbrella the whole term, but for the most part, it's the observation of stars, the movement of stars, and planets and other celestial bodies and things like that. Whereas astrophysics is more the measurement of stars.
Like how big they are, how overweight they are?
How big they are, the mass, how far away they are, how they're going to move, things like that.
The effects of their gravity and the gravity around them. Is
Correct.
that astrophysics?
Yeah.
Absolutely.
Is astrophysics also the study of other celestial bodies, not just planets?
Yes.
Yes.
So,
yes.
like, if we're talking about, like, the Oort cloud, that would be astrophysics?
All pretty much all astronomy, or all celestial bodies, anything
Quasars,
in
black
space.
holes.
Yeah,
And
absolutely.
going from the most broadest sense, could any science be labeled as astrophysics? Like, as broad, like talking about the chemistry of stuff on another planet, would that still be
Astrochemistry.
astrophysics?
It could, right? Because if we found life on another planet, I mean, there would be like astrobiology and stuff like that. But we would be looking at it from that perspective. Whereas a lot of the problem comes from us thinking about Earth as something separate from space, when really we're just a part of the whole system as it is, you know.
Okay, so astrophysics, the word is just for us. It's really just physics in the universe.
It is, yeah.
It is.
All of these words are just for us. I mean, nature doesn't really have any defining lines. We're the ones that put the defining lines there, so there's no natural separation between this. This is just words for us.
But I think that the sub-tending branches of astrophysics, like astrobiology, those are, I put a different viewpoint on a traditional science. Because with astrobiology, you're trying to look for biology that is not from Earth. Like
Sure.
you're trying to find something that's so outside of our understanding of current biology, because our biology is just our biology. It comes from Earth, and there's no way to look beyond that. So, I mean, we're kind of creating all these new branches.
Delineations?
Yeah, delineations. Yeah, that's
I
a
like
good word for it.
I like it. And then cosmology. That sounds like someone who's going to cut my hair. But that's cosmetology. So that's the science of cosmetics, and you need to not study that.
Well, hey. There's a lot of people employed. I look fantastic, don't I? But that's like the origin of the universe.
Yeah, cosmology deals more with the big picture. So, like right now, I have a picture of the Big Bang. Of the
Where'd they
expansion of the
get
Big Bang.
Where'd they get that photo, and who took it?
But cosmology deals with like the origin, how the universe evolved, and then the eventual fate of the universe.
Yeah.
So like when we deal with heat death and everything just kind of being nothing again.
This does kind of reach towards cosmology. It does kind of reach towards more natural philosophy, in the sense that the theories, though based in mathematics, still are not observed.
Right.
Like it's like Omega, the expansion of the universe, that can be observed. But like the Big Bang, we have information like the cosmic background radiation is all pointing towards the origin of the universe. But the thought experiments used to like bring up the Big Bang, like that's all unproven.
It's all theory.
Yeah, it's
Right.
It's definitely a different realm of thought science. So.
That would be, yeah. So that would be astronomy. Astrophysics is the mechanics of it, and cosmology is the whole big picture.
Yeah.
One thing I did want to note is, let's see, let me change the picture on here. Astrology.
Yeah. They got the better name.
I'm a
unfortunately.
Virgo right here.
Leo.
I'm a Taurus.
Oh, you're a lion. What are you?
I'm a Taurus.
I am
You're
not
a bull.
lying to you.
You're a lion. Roar. Are you like? Is it like Katy Perry? Am I gonna hear you roar?
No, you're
You know,
not.
I heard that Leos are very headstrong and that Tauruses are like an immovable object. Especially on
Thank
today.
you for highlighting why this is all bullshit.
when Venus is in reaction to Mars on exactly 3:31 and 45 seconds, you guys tend to be agreeable to what I'm saying now.
No.
So our reason for bringing this up is
Sorry.
to illustrate that, right?
Well, I feel, absurdist is fun, right?
Right, exactly. That's why so many people enjoy astrology, even though there's no basis in science.
Yeah. But it's actually, astronomy should be called astrology.
Right.
Yes.
Astronomy or astrology, like, literally translates to study of the stars.
Yeah. But the modern and the colloquial interpretation of astrology is going off of your birth sign, or it's literally a pseudoscience.
Right.
When you were born, what position the stars were in when you were born, and their relationship with the day that it is now has some bearing on your future, or
And your
present,
behavior.
and your behavior.
Your diet, your...
And how planets align and stuff like that.
But we
too.
should say that the study of astrology did lead to our understanding of astronomy now.
Oh, for sure.
Without that, there wouldn't be this. But we have to take all of the meaning of astrology. Like, if I saw a comment that there's going to be a great war, that is all out the window. Like, there isn't any, as far as we know, meaning between the two things.
Man, I would love to dig into like the falsehoods or the things to look out for in astrology if we ever get a chance.
Let's go over all
Peter's-
pseudosciences.
That'd be great too.
Yeah,
but
we should at some point.
I like the idea of like you said, like a comet is the harbinger of a war or a famine or
Something bad.
or it could be something good too. There were ancient civilizations that were like, oh, we're gonna have great prosperous crops, or the gods are smiling on us. Look, they sent a tail.
Yeah. And well, I mean, astrology goes even deeper than that now. At least it's in all of our newspapers. It's in writing, like in Game of Thrones, the comet that said the birth of the prince that was promised.
Right.
Like these are all elements of astrology that have gotten to popular culture, and now a lot of people may read their horoscopes in the newspaper and not connect the two things and not connect the history of that thing to now.
Yeah.
But I feel like most people these days don't believe in astrology. I mean,
That
you
it's
don't
a
have
fun farce.
Yeah, exactly. It's a fun farce.
Don't put too much. It's like a fortune cookie or something.
Yeah.
Right? They're
Fortune
fun to-
cookies have gone downhill.
Oh,
Either I have
they
aged
have.
up and I'm looking at them, I'm like, this is not even a fortune.
No.
This is just a statement.
This is just advice. I don't
Exactly.
You should go on a walk today. I'm like, maybe I will, yeah.
Save money, live better. Walmart. What?
They should start doing that. That's revenue stream for them.
All right. Well, let's move away from astrology.
Yeah.
We're gonna go into history now, which I know tends to be Josh's favorite.
I love history.
Favorite.
Let's talk about this ancient Greek named Eratosthenes that was the ancient astrologer who first accurately measured the circumference of the Earth. That's a fantastic feat, especially because he did it on foot.
He lived from 276 BCE to 194 BC.
Yeah.
But didn't he accurately measure it using shadows?
Yes.
Yeah, and sticks.
He measured it by the shadow, looking down. He figured out that at a certain time at noon, if you look down the well, the sun was directly above it.
Yeah.
So,
but then somewhere, some number of miles away, that wasn't the case.
Right.
Yep.
So based on that, he figured out that it was that section of Earth that he had measured was like 1/50th the circumference of the Earth.
Yep. So he just finished his equation.
Right. And apparently pretty accurate.
Very accurate. But I think that a lot of the inaccuracy comes with the units of measurement that he had access to at the time.
Was it hectares that he was using?
Well, units of measurement, and that he assumed that the Earth was a
Flat.
perfect circle.
Oh, that's
Yeah,
right.
it's
He
not,
assumed
which-
it was a perfect sphere,
That's right.
which it is not.
Yeah.
So it gets stretched by the sun's gravity. Real quick thing I wanted to point out that kind of went with what we were talking about knowing doing things a long time ago and forgetting them, is on the Wikipedia page for
Eratosthenes.
Eratosthenes.
I don't know.
Yeah, Greek.
In the book,
right.
In the audiobook Cosmos, they say Eratosthenes. So I mean, I'll go off that just because.
You know, if you read like the word Euripides, it does not look like it's spelled at all. It does not sound like it's spelled. Or epitome. All those Greek names, screw them.
Yeah, it's a different language.
Yeah.
It points out in the Wikipedia that 700 years after his death, Christopher Columbus had been studying his measurements of the Earth, but decided that they were wrong. And that's why that's what ended up leading him to believe that it was India that he landed on instead of a new world.
Yeah.
Oh, okay, gotcha. Who's Hipparchus?
So Hipparchus is considered the founder of trigonometry.
Okay. So he's that guy that I can blame for sophomore year. That was my trig class. So I understand that mathematics is the language of science, and without trigonometry, we wouldn't have modern calculus. So I guess we can thank him for that. But he was also the one to discover the precision of the equinoxes.
Right.
Yes.
Gotcha.
Which is amazing. Right? That's
for that time,
especially thinking it's still BC, right?
Mm-hmm. Yes. So his was 190 BCE to 120 BC.
60 or 70. Wow.
Yeah.
That's long.
Lived a decent life. Trigonometry is very, very important to us to calculate like distances and find things, and so.
Yeah. Yeah, I just remember not liking it in school. Probably because just like any other high advanced mathematics class, the teacher was very dry.
There was a lot of things that I didn't like in school that I enjoy now.
Yeah, I have the same.
One of them being history. I could not stand history.
I always loved history.
But without trigonometry, we wouldn't have flight. We wouldn't have advanced architecture. I mean, there's a lot that we wouldn't have without trigonometry. Vectors are very important for human life these days. So
and rocket launching.
Yeah, absolutely.
And then we're gonna jump ahead about 1,000 years or more.
Yeah,
1,200 years,
1,300 years, I think about.
To a young gentleman, you may have heard of him, named Nicolaus Copernicus. He was around during the Renaissance and Reformation era. And he's a mathematician and astronomer. He formulated the first working model of the universe with the sun at the center,
heliocentric,
as opposed to geocentric.
Right.
To use the Latin term.
Mm-hmm. Even though his model was far more accurate than the geocentric model, we're still a long way at this point from having our understanding of the universe.
Oh.
Because his thought was that the universe was revolving around the sun, when in fact it was just our solar system, among many other.
Yeah, he still thought we were galactic center.
Yeah.
Yeah.
Which is 15,000 light years somewhere else. So.
Yeah. We're just on this lonely arm of the Milky Way.
It takes a long time for people to think how unimportant we are. So
yeah, we'll probably get into that after we're done with the history part of this episode.
Fun fact: he lived to 70 also.
Really?
Wow! From 1473 to 1543.
There's a pattern here for geniuses.
So they come in 70s. From there, we move on to, I would say, the David Bowie or Elton John of modern astronomy, one of the most influential and important people ever, Galileo Galilei. He's Italian.
Dope name.
And yeah,
that's a really cool name.
Hey, how much do you guys like your family? We're gonna name our kid's first name after us. That's how much we like our family. He's a major role in the scientific revolution of the 17th century. His contributions to observational and the observation and analysis of sunspots and modern astronomy were incredible. A lot of people recognize him as just the guy who looked through the telescope and discovered Jupiter and its moons.
Right.
But he's more than that.
Absolutely.
Yeah, far more than that.
Another reason why he's so iconic in the world of science and the scientific revolution is because of the problems that happened with the Roman and Catholic Inquisition surrounding his theories and stuff. He was considered a heretic. First of all, not only for backing up Copernicus's theory of a heliocentric solar system, but also to say that the Earth was not like divinely made.
Yeah.
Right.
Let's see. He was eventually criticized as foolish and absurd in philosophy and formerly heretical, since it explicitly contradicts in many places the sense of Holy Scripture. He was tried by the Inquisition and found vehemently suspect of heresy and forced to recant. He spent the rest of his life under house arrest. Then we move on to, what was Galileo's, do you know his dates, by the way?
Oh, I don't. Let me see. I didn't look that up.
Because we got to go to Kepler next, and they're around the same time, or at least same time relatively.
Hold on one second. I will. So 77. That's how he lived to an age of 77. 1564 to 1642.
Okay. It was in 1615 when he first concluded the heliocentrism of the solar system, again with Copernicus' work before him. So then we move on to Johannes Kepler, a German mathematician, astronomer, and astrologer. He was also another key figure in what is known as the scientific revolution. It was in the 17th century. And he is best known for coming up with the laws of planetary motion, as well as being some of the basis for what Isaac Newton's work would be when he came around.
Yeah.
Do you know what his lifespan years were and all that stuff?
Kepler?
Yeah.
He lived from 1571 to 1630, so he only lived to 58.
Yeah, and he died before Galileo.
Yes, yeah.
It's funny. This happened. We've also got a biology episode coming up, and that happened with Gregor Mendel and with Charles Darwin. They together, these guys, Galileo and Kepler, are responsible for a lot of what we know today about planetary motion and our solar system, right? The same thing happened with Darwin and Mendel when it comes to theory of evolution. I don't know. It's a nice little coincidence. That's very interesting, Josh. I digress.
I think it's interesting with Galileo and Kepler, that what they decided to spend their time researching ended up being really beneficial for us, because when they were looking through Galileo's journals, they found that he had been testing acceleration and gravitation with marbles, and he has research pertaining to universal gravitation. But at one point during his journal, he's like, I think that it's not important for me to be researching gravitation or the force that moves these bodies.
So Kepler is the one that does it.
Exactly.
2 countries away.
Yeah.
Nice.
But they were both on to something there. But Galileo was like, I got more important shit to do.
Right.
Apparently.
This telescope over here is calling my name.
All of these geniuses end up having this weird period where they're either forced to stop their scientific pursuits, and just think of what more Galileo could have discovered if he wasn't, suppressed, essentially.
For sure, yeah. From Kepler and Galileo in the 17th century, we actually enter a new age of enlightenment in the world of Cambridge, and through a man named Sir Isaac Newton. He was knighted posthumously, wasn't he?
Yes, he was.
Yeah. I mean...
Though he was still famous during his living years.
There's no one in the world of physics, of mathematics, of pretty much any basis in science outside of biology that Newton is not known and touted for. He's like the father of modern
Newtonian
science.
Physics.
Yeah. This guy, Peter, you probably know more about him than any of us, having studied a little bit about Newton. Why don't you drop it like it's hot?
Chip!
Here comes the debase.
Isaac Newton, born in 1643, started out as a really poor farmer. I can't do it, though. I have no lyrical genius whatsoever.
It's okay. I can't do beatboxing.
While he was a farmer, he actually had zero interest in being a farmer. So much so that the local municipality, I'll call it, kept fining him because he wouldn't repair his fence and his sheep kept eating
other people's stuff. Yeah.
And so once his family found out that he didn't have any interest in it, because he was more interested in making water clocks than actually farming, his family paid for him to go to the University of Cambridge. But while at Cambridge, they kind of had these three sects of students. They had this really low-class student that essentially was the bitch boy, kind of like the Maesters, actually. And maybe that's where he got it. It was from University of Cambridge. But like he had to go clean the shit pots in the rooms of all of the wealthier students. And that's how he kind of paid his tuition, because his family disowned him because his real father died and his mother remarried. And so she kind of forsook him so that like all of her dowry would go to his children instead of Isaac Newton. Eventually, Newton got a professorship at Cambridge once it was discovered that he had taught himself trigonometry and geometry from the original publications, which are all mostly in Greek. So he had to teach himself language. And actually, he had this rubbish journal, which I'm just going to kind of touch on, where he put all of his axioms for for the laws of motion and stuff before he actually published his paper. In there, he created his own cipher, which was this universal. He invented a universal language based off all of the languages that he had learned. And he's like, if the whole world spoke this, it would be great, essentially. But he never ended up publishing it. But eventually, the plague started spreading through Europe, and the University of Cambridge was closed. He was forced to move back into the country with his family. But this was a really good thing for humanity, because he stopped learning what was known and started looking at the unknown. And at that point, when he stopped learning the known, is when we started getting all of his best work.
Right. Celestial motion.
Yeah, so he was obsessed with this stuff. So much so that he invented or possibly rediscovered a new form of mathematics in order to understand the motion of celestial bodies.
Calculus.
Yes, calculus. And then he published his findings in this big book. I'm going to try and say this. The Philosophica Naturalis Principia Mathematica, which is the mathematical principles of natural philosophy, which is a really weird way of putting that whole thing.
Yeah.
But everything back then was still considered philosophy to the Royal Society, which he was a member of. But he summed up all that was known about mathematics, which at that time you couldn't do. You had to go back and read math from Greek books. Yeah, exactly, and relearn that. So he condensed it all together, and then he introduced his new calculus branch of mathematics, which revolutionized everything.
Well, it's another way of expressing the things that they were trying to express. Of course, it was revolutionary. That's like when moving pictures happened. People had a new way of expressing themselves. Of course, it's revolutionary. You know what I mean?
That was more precise than the last.
Absolutely. Yeah, it's exactly what I'm talking about. Yeah.
And his infinitesimal calculus was so precise that he used that to express the relationship between gravitational bodies. And because before that, gravitation was theorized, but it was just like it was a distinct sphere. Like if you were outside the sphere of influence, the body no longer had any effect on from the gravity of the planet that it was inside the sphere of influence. But he was the first to go it's actually a relationship. The further away you are, the weaker it becomes. And he used his infinitesimal calculus and derivatives and integrals to prove that was the case.
Yeah,
but
we still use those to go to space.
Yeah,
absolutely.
To land Curiosity on Mars.
And there's very little revision to his model of the universe.
Where it's supposed to go.
Point Voyager. I was trying to remember the Pluto.
Voyager 2? God.
New Horizons.
New Horizons.
Yeah, I'd like to get New Horizons all the way out there, and the so many years that it flew through space,
and to predict where Pluto would be.
Right, exactly. That's all Newtonian gravity that we did that with.
And this is as far back as 1687.
Yeah.
So what is it? Galileo died in 1635. So 50 years later, Newton had everything. He had it ready, and that's amazing. Just to think about that level of genius, I could say now I'll never do that. I mean, I might be able to.
They predict his IQ to be around 195.
Really?
Yeah.
Wow.
So he was actually smarter than Einstein.
Yeah.
But he too had to build off of what was already known. I mean, past scientists like that, all of that foundation work he needed to get as far as he did to make the laws of motion and gravitation. But in order to observe what he had discovered, he more or less pushed optics far past what anyone at the time knew about optics. I mean, he published a book called Optics with a K. I'm assuming that's Latin.
That or it's an old British thing.
That could be an old British thing.
Like how color has a U in it.
Oh God, it does, doesn't it?
Yeah.
And behavior actually in England is different than behavior here. So I know.
Yep.
Yeah, that makes sense. Well, but he discovered he was able to discover all the different component colors and how they were mixed together to create white light. And then he
he had the first prism, didn't he?
He created one of the first prisms. Although lenses on sideways back then could be used to make prisms.
Okay.
But he was the first to make a parabolic mirror and put it in a telescope and catch more surface area light for his telescope than any telescope before it. And so using that,
using a convex.
Yeah.
Okay,
and so it had this conic parabolic shape down to, and it would catch the light and it would reflect that to another mirror and then to a lens. But that it collected more light than all the refraction-based telescopes at the time, which is just incredible. I mean, he pushed us so far ahead in just that one way, and that was just him idly going like, oh, I invented calculus and I predicted the motion of planets. I want to go see if I'm right. Yeah. And so he made this telescope to see if he was right, and voila.
Yeah. We will spend an episode for sure on
absolutely.
Newton.
He's so important to even our culture nowadays.
Yeah. So, but let's move on to another member of the.
Oh, did we ever say how long Newton lived?
No.
84 years.
Okay, so the 70 rules out.
From 1642 to 1726/27.
Nice. Next on our list, we're going to jump ahead into the 18th century. William Herschel. He constructed the first large telescope. Like, when you think of observatories, this is the guy that made the first observatory telescope. And it was still 2 years before the American Revolution. Mm-hmm. And this guy's German? Herschel's a German name. So either he was in America or he was a German astronomer. But this guy was able to, basically, he built upon, just like the scientists before him built upon the scientists before them, he built upon Newtonian physics and Newtonian ways of doing things and made a massive telescope. Mm-hmm. Awesome.
Yes, he was German, according to his Wikipedia page. And he lived to be 83, so 1738 to 1822.
So plus or minus 15 is where we're at, right? Or 70. So the theory could still be a thing. I'm gonna hold on to it for as long as I can.
He also created temperature measuring equipment that allowed him to determine the different spectra of light as far as their heating/cooling natures. The difference in the wavelengths is what I'm getting at.
Right, okay.
Blue wavelength is shorter, but red wavelength is longer, and determining how that light is either moving further or closer to us. Yeah. You know what I mean? That's a very horrible way to describe it.
The redshift?
Yeah.
Redshift?
Color shift or whatever.
Mm-hmm. Yeah. Colors always shift further into the red spectrum. So that's how you can tell how fast they're moving.
Yeah.
And then how far away they've moved.
We have a telescope named after him, but we're going to go with Edwin Hubble. This guy is an American astronomer. He played a crucial role in establishing extragalactic astronomy and observational cosmology. He's regarded as one of the most important astronomers of all time. This guy was the one that decided to start calling the clouds of gas and particles in the space nebulas.
Mm-hmm. Good name.
Yeah. And obviously most well known for his name on the best space telescope in use so far.
Right.
Good. Yeah.
Distinction.
Yeah, exactly.
Yeah.
I mean, considering we're about to put a different one up there.
Yeah. James Webb.
All the way. I'm so pumped to see pictures from that thing.
No kidding, right? You're like, is it still on its way, or is it there? Is it on its way? Is it there? Is it there? Okay, give me pics. Come on. Pixar didn't happen.
Hubble also did a lot of work with the Big Bang model and the expansion of the universe too.
Yeah. So we spent a lot of time on Newton here, but we'll spend time on all of these guys and more. I mean, we didn't even talk about Einstein, who definitely had affected space and astronomy.
Yeah.
Special relativity.
Talk
black
about
holes.
building on top of what other people have done. I mean, he pushed what Newton had made and created an even greater and more accurate model of the universe.
Yeah. But we should mention Stephen Hawking. I think we'd be remiss not to mention him.
Absolutely, yeah. His work with black holes
and
Hawking radiation.
And we can definitely mention, Carl Sagan, as a scientist himself, did a lot of work with Venus that we should mention. Neil deGrasse Tyson is still doing research in astrophysics, so there's no reason not to talk about him as well.
Absolutely. There's so many people we could be talking about. So,
and now as we kind of wind around towards the back half of this episode, Adam, why don't you take us away into what is most exciting to you about astronomy, astrophysics, and
most exciting to me? Well, I don't know. I love most of it.
I love lots of stuff.
Whereas we've been going a lot over history, I'm also very into like futurology and stuff, and where the universe is going, and things like that are extremely interesting to me. Colonization. We've talked. We will talk about, I guess, like space-time, fabric of space-time, bending space-time.
The shape of the universe, essentially.
Yeah, exactly. And made some theories of like what the universe is made out of. What is the fabric of space-time?
Also, dark matter. What is that?
Dark matter, dark energy. Exactly. Yeah, we will definitely have a whole episode on dark matter and dark energy, I would think, because there's a lot of that could lead to some good discussion.
And the expansion and compression of the universe.
Absolutely.
Omega.
I like the Flat Earth Society. I think that's a great thing. I like that most people think that we're still a geocentric part of the cosmos. I love the ignorance around astronomy. As far as from my perspective, like we covered a lot of the stuff that I like about history. There's nothing cooler to me than learning about the people that broke the bonds and questioned the natural way of things and showed that, oh, this is actually how it is, as opposed to accepting what they're told from an institution, from the people that came before them, whatever. Right. That's one of my favorite things about science in general is just the breaking through of barriers. Another one of the things that I like about astronomy is Carl Sagan calls it the science of humility. Then famously spoke in about a 3-minute space about it in Pale Blue Dot. We are a speck on a mote of dust suspended in a sunbeam. There's nothing special about humanity, and the way to show that is the size and scope of the universe.
Makes you more unique and insignificant simultaneously.
I would say more insignificant, which is fine because I felt insignificant for the most of my life.
Well, I mean, if in Carl Sagan's book Cosmos, he talks about that insignificance, but he also talks about how he goes over the mathematics and probability of finding other life in the universe, and then he ends up coming up with this equation, or illustrating a known equation. Yeah. And honestly, it makes you feel insignificant, but at the same time, really special to know how rare life is in general.
From as far as we can tell, absolutely.
And the last thing that I really enjoy about astronomy is the romanticism that we attach to it as humans. On Waiting for Players, we spent a lot of time talking about the Juno mission and how in ancient Greece, Juno, or ancient Rome, Juno was the wife of Jupiter and was the only one who could peer through the clouds to see what Jupiter was doing with his mistresses. The mission to Juno is going to Jupiter and surveying Jupiter and its moons, and the moons are all named after Jupiter's actual mistresses. But just beyond that, the way that we name celestial bodies, the way that we consider ourselves as on Earth or Terra, and that the king of the planets is Jupiter, of course, and he's the king of the gods. Venus, the goddess of love, she's the one closest to us between us and the sun. Mercury, the messenger god, is the one who moves fastest around the sun but is rarely seen. And then Pluto, the god of the underworld, he's furthest out and not even a planet anymore. Go screw yourself.
It's funny how accurately that describes the behavior of celestial bodies without them actually knowing what they were or how they were moving exactly. Yeah. So, and how accurate, I mean, it is. Jupiter is king of planets. Let's be real.
For real.
Absolutely. And that would be a fun thing to do too. Go through the whole solar system.
Yeah.
Kind of take a closer look at. Yeah, exactly.
Especially with what we know from Cassini and Juno right now.
Yeah.
Especially with what we've seen coming from
horizons.
Yeah. With what we saw of Pluto and how it has a whale tail. I mean, a heart.
We got some amazing pictures of Pluto. And still surprising.
I was remiss. So. This is episode 3. I called it episode 2. Oh well. My bad. because we just talked to Steven last episode. What about you, Pete? What is enthralling to you about astronomy, the universe, and everything?
I think that I'm more interested in cosmology, but I was reading a lot of Carl Sagan's book recently, and before that, I was reading Carl Sagan's book Contact. And unlike the film, there's actually this really cool, I don't really know what you'd call it, but I don't really believe in God, or a higher power, and that's something that you always kind of struggle with when you've decided to be an atheist. That there's this almost like void, where like there's meaning that's lost there. But in his book, he's talking about once they've met the aliens in the book Contact, they were like the main character was asking this alien, where do you guys find meaning? Like what do you do? Where is your search? Because they're searching for alien life, and she wanted to know what they were looking for. Mm-hmm. And so then he said, if you calculate the digits of pi out to a billion, right, there'll be this code embedded inside the irregularity of pi. And what I thought was really interesting about that is that it's this kind of like there's a creator, and the creator is leaving people breadcrumbs like, hi, I'm here, I created the universe. and that's what these people are looking for. But then when you hear about like the cosmic background, like the beginnings of time, then you realize what light actually is and how you perceive the universe through this essentially time traveling.
Ghosts of light.
Yeah, and so it draws me in to cosmology because it makes me feel like there is a connection between everything, between me and those other things, and that it gives my life meaning because even though we're insignificant, we're also really important. Yeah. Like what we're capable of doing as humans, and what we're a part of something, even if it's insignificant, that can carry on to the future and have huge impact on the universe.
Yeah. Absolutely.
As more and more and more as we go through the cosmos, and the more we learn about the cosmos, you're going to get better science fiction.
Yeah.
Yeah, absolutely.
Any fiction writer worth anything, and I'm thinking specifically of like the guy who wrote The Martian. Mm-hmm. He did his research first and then gave us a compelling story.
Yes.
Yeah.
So there's no reason why, as we break through in science, that you cannot popularize that through science fiction. And I think that's a goal that we should do moving forward.
And I want to support that point actually by saying, like, in animation, when we get to when we finally get to animation, like in the time of Walt Disney and stuff, they created rules of animation, and one of them was real but exaggerated. Yep. And so when you look at really smooth animations that are appealing to the eye, those animations are appealing because they are based off of something known. They're based off of like a spring, right? Off of these real physical objects.
Oh, okay.
And so something is more compelling, like fantasy or like science fiction, when it's based off of something real.
So another way to think of that is think of like a cartoon steak. That steak is probably the most delicious thing you've ever seen because it's based on the ideal schema of a steak.
Yeah.
Or how about this? You can also do it from sound effects wise. Think about it's a crude example, but think about when you hear someone urinating either over a speaker or like during a movie. Mm-hmm. That is the quintessential sound of someone urinating, not necessarily that they actually fully captured someone urinating.
Right. Yeah. Right.
So I like that. It's a good analogy.
Yeah. It brings something to it by taking something that's real and fascinating about the real universe and tweaking it, and now it's science fiction, now it's fantasy.
But
and sometimes that's predictive, funny enough.
But it's still adhering to that schema.
Absolutely. The purely abstract steak or the purely abstract animation. But I feel like if you like Star Trek, right? There's a lot that's based in science, and then they just take it a little further, and then there's all this pseudoscience surrounding it, but it always makes it feel more real and more compelling.
I have a communicator. We all do. I think we all have a communicator.
A tricorder right here.
Yeah, it's a scanner. It's a camera. It's a phone.
It's got a lot of sensors on it. It's got a barometer.
In the World's Fair, this was science fiction. Right. At the 1939 World's Fair, this was fake.
Mm-hmm. Headphones, science fiction.
Yeah. Now it's
1984. Now it's real.
It's absolutely real. So there's no reason that science cannot be popularized, especially when you think of it as interesting as it actually is. Yeah. With that, we'll be covering biology next. No, wait. We got one more astronomy one that we're gonna get through next, and then we'll be doing some biology next time. So for Science Nights this week, bye.
Thank you.
Goodbye.